Assalamualaikum warahmatullahi wabarakatuh. So this is the lecture video for week 7. Okay, we are still in chapter 3. Okay, the second subtopic. Okay, in chapter 3, there is about the analysis of function. Okay, so this time apa yang kita nak buat analysis of the function. So we want to know about the increasing, decreasing and the concavity. Okay, we want to know whether the graph of the function is increased or the graph of the function is decreased, and how about the concavity of the function, of the graph of the function, whether it is concave or convex, or concave up or concave down. Okay, concave down tu kita sebut sebagai convex lah. Okay, concave up or concave down or convex kat sini. Okay. Okay, the first one is about increasing and decreasing. Okay, how do we know whether the function is increasing or increasing at a certain interval? Okay, please look at theorem 3.1. Okay, this is the theorem for the function is this is the theorem for us to know whether the function is increasing or decreasing at certain interval. Okay, the first one is if f prime x, okay, more than 0, meaning that you need to differentiate the function. Okay, and then insert a certain value x, where the value x is must be between a and b. Okay, so calculate, and then kalau dapat value dia more than 0, so meaning that the function is increasing at that interval. Okay, so interval ni dia akan kita akan cari dululah interval ni. Nanti saya akan tunjuklah macam mana nak cari interval tu. And then second one is if f prime x less than 0, okay, differentiate function tu and then masukkan nilai x. Nilai x ni mesti antara interval ni. Okay, contohnya dia bagi interval between -1 and 3. So you pick a number between -1 and 3. Tak kisahlah nombor apa-apa yang antara -1 hingga 3. Masukkan dalam f prime tadi. Kalau dapat nilai less than 0, it means that the function is decreasing at that interval. And the third one is if f prime x equals 0, okay, so the function is not increased and not decreased, so it is constant. Okay, so macam ni lah. Kalau graph ni increasing, dia akan naik macam ni. If the graph is decreasing, turun. And then ni increasing. Kalau constant macam ni. Okay. So this is the step to determine whether the function is increased or decreased. Okay, the first one is find all value of for x which f prime x equals 0. Okay. You set up f prime x, differentiate that function and then equalskan dengan 0. And then find the value of x. So from that value of x, we can create the interval. Okay, second step, we need to test a point C in each interval to check the sign of f prime C. Okay, using the previous theorem. Okay, theorem 3.1 ni. Kita nak apply theorem 3.1. So if f prime c more than 0, so it is increasing. F prime c less than 0, it is decreasing. Okay, look at this example. Example 3.9. Okay, the question is find the interval on which this function is increasing and the interval on which it is decreasing. This is the given function. So we need to find which interval is increase and which interval is decrease. So first we need to find the interval first. Okay, interval. Nak cari interval using the first step. Okay, first step we need to set up f prime x equals 0. Okay, f prime x equals 0. So inilah yang kita nak kena set up. So f prime x, so maksudnya kita differentiate this function. So differentiate this function, we'll get 2x minus 4. So 2x minus 4 equals 0. Okay, so solve this equation, we'll get x equals 2. So x equals 2, meaning that our number line 2 is here. So kalau ada 2 dekat sini, kita boleh dapat satu interval, dekat sini dapat satu interval. Okay, the first interval is negative infinity until 2, daripada negative infinity sampai ke 2. Second interval is to infinity. So based on this value of x, we will get 2 intervals. Okay, and then pick our C. C is the test point, ataupun kita boleh tulis kat sini test point. Okay, so pilih apa-apa nombor yang antara negative infinity hingga 2. So let's say kita pilih nombor 1. Dan kat sini kena pilih apa-apa nombor between 2 and infinity. So let's say we choose number 3. Okay, so ini adalah test point. So test point ni kita masukkan dalam f prime x. So our f prime x is 2x minus 4. So x equal 1 ni masuk dalam ni. So 2 times 1 minus 4. So we will get negative 2. So negative sign. And then insert our test point, which is x equal to 3, into f prime x. So 2 times 3, it is equal to 6 minus 4, it is equal to positive 2. So positive number. So negative means decreasing, positive means increasing. Okay, so kita jawablah macam ni. The function is increasing on decreasing decreasing yang ni sebab kita dapat negative value. Okay, so the interval of decreasing is here between negative infinity until 2, and interval of increasing is to infinity. Okay, senang je kan nak cari interval of increasing and decreasing. Okay, we look at another example. Okay, similar example yang ni dengan example yang tadi. Okay, this is the function given. So we want to find the interval that is increasing, decreasing or constant lah kalau ada. Okay, then first step sama, kita apply first step sama yang macam tadi. Kita kena set f prime x equals 0. So f prime here is 2x minus 5. So 2x minus 5 equals 0. And then solve for the value of x, we'll get x equal 5 over 2. So 5 over 2, kalau dalam number line 5 over 2 kat sini. So meaning that we can divide this number line into 2 intervals. Okay, the first interval is negative infinity until 5 over 2. And then the second interval is between 5 over 2 until positive infinity. So kita dapat 2 interval lah. And then kat sini test point. Test point. Okay, antara negative infinity hingga 5/2, kita pilih satu nombor. Contohnya pilih nombor 2. Kat sini kita pilih satu nombor, contohnya kita pilih nombor 3. And then insert this test point dalam f prime x. Dalam ni lah. Okay, our f prime x is 2x minus 5. So 2 masukkan dalam ni. So 2 darab 2, 4. 4 tolak 5, dapat negative answer. And then insert 3 in f prime x. So 3 multiply with 2, 6. 6 minus 5 equals 1. So kita dapat positive answer. Negative answer means it is decreasing, and positive answer means it is increasing. So kita buat ayat macam ni lah. The function is increasing on, increasing yang ni kan, on, decreasing. The function is decreasing on this interval. Okay, and increasing on this interval. Okay, constant tak ada. Bila masa dapat constant, kita tengok dekat dalam teorem tadi. Okay, constant kalau f prime x dia equal 0. Okay. Next example. Okay, example 3.11. Find the interval of which x cubed is increasing and interval which is decreasing. Decreasing and increasing interval lah. Okay, we apply the same step as before. First, we need to find f prime x and then set upkan dia equal 0. So, from this function, our f prime x is 3x square. So, kita equal dengan 0. So, solvekan dapat x equal 0. So, x equal to 0, kalau dalam number line, 0 is here. So, we can divide this number line into two intervals. Okay, the first interval is negative infinity until 0. And then second interval is 0 until positive infinity. Like this one kat dalam table yang kita buat ni. And then kita punya test point. Okay, pilih satu nombor. Tak kisahlah pilih nombor negatif 1 ke, negatif 4 ke. Asalkan nombor tu antara negatif infinity hingga kosong. Okay, and then between 0 until infinity, kita pick any number. Okay, let's say kita pick number 1. And then masukkan dekat dalam f prime x. Okay, f prime x kita tadi apa yang ni? Okay, masukkan negatif 1 dalam ni, dapat negatif 1 kuasa 2. Jadi, positif 1 darab 3 akan dapat jawapan positif. Okay, 1 pun masukkan dalam ni akan dapat jawapan positif. So, both intervals are positive. So, meaning that both intervals are increasing. Okay, so f is increasing on negative infinity 0 and 0 infinity. Okay, so maksudnya function ni dia akan increasing saja, tak ada decreasing. Okay. Okay, the next example yang ni. Function yang ni dia bagi function yang ni. So, kita apply same step. The first step is we need to find f prime x and then equalkan dengan 0. So, from here, f prime x kita adalah 12x kuasa 3 tambah 12x kuasa 2 tolak 24x. Okay, equal 0. So, kat sini kita nak solve the value of x. So, kita kena factorize lah. Factorize. And then, bila kita factorize, kita akan dapat 3 bracket macam ni. So, maksudnya kita akan dapat 3 jawapan. Jawapan negatif 2, 0 dan 1. So, let's say kita ada number line. Negative 2 is here. 0 dekat sini. 1 dekat sini. So, maksudnya daripada number line ni, kita boleh tengok kita ada 4 interval. First interval kat sini. Second interval kat sini. Third interval kat sini. Fourth interval kat sini. Kita ada 4 interval. The first interval daripada negative infinity sampai 2. Second interval, negative 2 hingga 0. Third interval, 0 until 1. Fourth interval, 1 until positive infinity. So, ada 4 kat sini. Berbeza sikit dengan solution yang ni tadi. So, yang ni kita ambil test point. Okay, contohnya daripada negative infinity hingga negative 2, kita pilih negative 3. Kat sini kita pilih negative 1. Kat sini kita pilih 0.5 lah contohnya. Kat sini kita pilih 2. And then insert into f prime x. This is our f prime x. Okay. So, masukkan nombor-nombor ni dalam ni. So, kat sini kita akan dapat jawapan negatif. Meaning that it is decreasing. Kat sini akan dapat jawapan positif, increasing. Kat sini akan dapat jawapan negatif, decreasing. And then kat sini akan dapat jawapan positif, increasing. So, the function is increasing on this interval and this interval. And increasing on this interval. Okay. So, maksudnya bila kita lukis graph untuk function ni. Ni y-axis. Sini x-axis. Okay. Y-axis dekat x equal to 0 lah kan. Antara ni dengan ni, dia akan graph dia ke bawah. Antara negatif infinity hingga 2, negatif 2 hingga 0, graph dia naik. Antara 0 hingga 1 pula, graph dia turun. Antara 1 hingga infinity pula, graph dia naik. Lebih kurang macam ni lah bentuk graph dia. Okay, that's how we find the interval of increasing and decreasing. Okay, second thing is, how do we find the concavity and the inflection point? Okay, to find the concavity, we need to find f double prime x, meaning that the function we need to differentiate twice. Differentiate dua kali. Okay, f double prime x. So, if f double prime x lebih besar daripada kosong, so maksudnya dia increasing slope. Okay, dia akan jadi concave up. Bentuk graf ni akan jadi concave up. If f double prime x less than 0, okay, will be concave down. Bentuk graf dia macam ni lah. Okay, concave down. Tapi kalau f double prime x equal 0, dia akan jadi tak ada concavity. Okay, zero concavity. Okay. So, concave up bentuk macam ni, concave down bentuk macam ni. Macam mana nak tahu bentuk dia? Kita kena cari f prime x, tengok lebih besar ataupun lebih kecil daripada kosong. Okay. So, macam ni lah saya cakap tadi, concave up, f double prime x more than 0, concave down, f double prime x less than 0. Okay, sama tulis kat sini. Okay, and then inflection point. How do we find the inflection point? Okay, sebelum tu kita tengok apa maksud inflection point. Inflection point is mark the place on the curve where the rate of change y with respect to x change from increasing to decreasing. Macam tadi kan. Okay, macam tadi kita tengok kat sini dia decrease, lepas tu increase. Okay, antara decrease dengan increase, point tengah-tengah dia kat sini. So, maksudnya ini inflection point dia. Kat sini pula increase, lepas tu decrease. Antara tengah-tengah antara increase dengan decrease, iaitu dekat sini, ini adalah inflection point. Okay, so itu maksud inflection point. Point di mana dia memisahkan antara antara dua bentuk. Okay, contohnya dekat sini. Ini concave up. Okay, ini bentuk concave up. Lepas tu ni bentuk concave down. So, antara concave up dengan concave down kat sini kita panggil dia inflection point. Okay, yang ni pula concave down, yang ni concave up. So, antara concave up dengan concave down, point tengah-tengah ni kita panggil inflection point. Okay, yang ni tak perlu tengok. Okay. Ni contohnya ini bentuk concave up. Ini bentuk concave down. Ini kita panggil dia inflection point. Okay, dan yang ni concave down, ini concave up. So, ini inflection point dia. Okay, macam mana kita nak cari inflection point? Kita tengok example ni Example 3.13. Okay, given this function, so find the interval of increasing and decreasing and concave up, concave down. First kali kita tengok yang increasing, decreasing, and then kita tengok yang concave up, concave down. Okay, untuk increasing, decreasing, ini salah ni dekat sini. Untuk increasing, decreasing, kita kena set up f prime x kan, equal 0. Macam tadi, example yang tadi, f prime x equal 0. So, our f prime x, bila differentiate dekat sini, akan dapat 3x kuasa 2 tolak 6x. So, 3x kuasa 2 tolak 6x equalkan dengan 0. And then solve for the value of x. So, we'll get x equal 0 and 2. Okay, so number line, 0 dekat sini, 2 dekat sini. Meaning that we can divide this number line into 3 intervals. Okay, the first interval is between negative infinity until 0. Second interval is 0 until 2. And third interval is between 2 and infinity. So, kita dapat 3 interval lah dekat sini. And then, ni test point. Ni sama macam solution tadi untuk cari increasing, decreasing. And then, kat sini kita dapat positif, negatif, positif. So, maksudnya increase, decrease, increase. So, buat ayat ni, conclusion ni. Okay, untuk cari concavity pula, sama ada kita nak tahu dia concave up, concave down. Okay, kita kena setkan f double prime. F double prime x equal dengan 0. So, yang tadi f prime yang ni, so maksudnya kita kena differentiate lagi sekali. Differentiate yang ni. 3x kuasa 2 tolak 6x differentiate jadi 6x tolak 6. Okay, 6x tolak 6. So, 6x tolak 6 ni kita kena equalkan dengan 0. And then, solve for the value of x, will get x equal 1. So, kalau x equal 1, maksudnya kita 1 je kat sini, kita ada 2 interval. Okay, between negative infinity until 1 and between 1 until infinity. And then, kat sini kita buat sama, test point. Kita ambil satu point yang berada dalam interval. And then kat sini kita masukkan sign of f double prime x. Okay, meaning that we insert the test point into f double prime. Okay, 0, 6 times 0 equals 0, minus 6. Okay, we'll get negative number. And then 2 masukkan dalam ni, 6 times 2 minus 6 will get positive number. So, negative meaning that it is concave down. Positive meaning that it is concave up. So, kita buat ayat macam ni. The function is concave down on this interval and concave up on this interval. Okay, you all tengok dua-dua table ni lain. Table ni untuk kita cari increasing and decreasing interval. Table ni untuk kita cari concavity, concave up and concave down interval. Beza dia apa? Dekat sini, point ni kita dapat daripada f prime x equal 0. Interval ni pula kita dapat daripada f double prime x equal 0. Okay, so dekat sini, sign of f prime, ni sign of f double prime. Okay, tengok perbezaan dua table ni. So, untuk cari increasing, decreasing interval, kena buat table macam ni. Kalau nak cari concave up, concave down interval, kena buat table macam ni. Okay. Let's take a look at more example. Okay, you are given this function. So, nak cari increasing, decreasing, kita kena cari dekat sini, f prime x equal 0. Okay, f prime x equal 0. So, differentiatekan function ni akan jadi 2x tolak 3 equal 0. So, selesaikan dapat x equal 3 over 2. Okay, meaning that the interval is negative infinity until 3 over 2 and 3 over 2 until infinity. So, buat test point and then insert into f prime x. So, you'll get here is negative decreasing and here is positive increasing. Ayat ni perlu buat Ini ada markah dekat sini conclusion dia. Okay, to find the concavity, kita kena cari f double prime x. Okay, f double prime x meaning that we need to differentiate lagi sekali yang this function. Okay, yang ni f prime. Kalau f double prime differentiate lagi sekali, kita akan dapat 2. Okay. So, kita tak ada unknown x kat situ. Tak ada unknown x. Macam tadi kan, yang example tadi, f prime x, f double prime x kita dapat ni. So, kita find the value of x. Tapi yang example ni, f double prime x, kita terus dapat constant. Okay. So, kita boleh nampak constant is lebih besar daripada kosong. So, bila kita dah dapat macam ni, maksudnya dia tak ada inflection point. Okay, inflection point adalah point yang ni. Ni kita panggil dia inflection point. Okay, bila kita set up f double prime x equal 0, selesaikan x, this is the inflection point. But for this question, we don't have any inflection point. Okay, tak ada inflection point. So, bila kita cari f double prime x, jawapan dia dah more than 0, meaning that it is concave up everywhere. Okay, maksudnya graph function tu hanya ada concave up saja. Tak ada concave down. So, maksudnya tak adalah inflection point. Sebab inflection point kan adalah point yang tengah-tengah yang memisahkan antara dua bentuk tu. Okay, so ini case yang soalan yang tak ada inflection point. Okay, another example. Okay, given this function. So, untuk cari increasing, decreasing, f double prime x equals 0. So, this is our x double prime equal 0, and then selesaikan dapat X yang ni. Okay, X yang ni. So yang ni kita dapat bahagikan kepada dua interval. Okay, negative infinity and until negative 1 over 2 and negative 1 over 2 until infinity. And then untuk cari increasing decreasing, kita kena cari test point kat sini, test point. Okay, let's say kita pilih nombor ni and then masukkan dalam f prime x. Okay, kat sini dapat positif, positif meaning that it is increasing, increasing. Okay, itu untuk increasing decreasing tadi. So maksudnya dua-dua interval ni increasing. And then untuk concavity pula, kita nak tahu dia concave up or concave down. So we set up f double prime equal 0. Okay, f double prime yang ni differentiate lagi sekali equal 0. And then solve for the value of x. So kita dapat value x yang sama. Sebab itulah dia satukan, combine the table into one table lah. Okay, sebab kita dapat interval yang sama. So ini row untuk yang inflection point. So sign of f double prime x kat sini dapat negative, positive. So negative meaning that it is concave down, positive meaning that it is concave up. Okay, so kena buat conclusion lah dalam bentuk ayat macam ni. Okay, next, analysis of function 2. Okay, we want to know about the relative extrema and graphing the polynomial. Okay, we straightly look at example 3.16. Okay, given this function. Okay, ni tengok explanation dia. Since f prime x is 2x minus 5. So 2x minus 5 tu kita setkan equal 0. So kita dapat nilai x equal to 5 over 2. So 5 over 2 is the relative extremum. Okay, relative extremum. Relative extremum means that relative extrema or relative extrema means that minimum point or maximum point. Okay, minimum point or maximum point. So macam mana nak cari minimum point and maximum point? Okay, kita tengok ada tak example kat sini. Okay, ini example 3.18. Okay, find the relative extremum for this function. Okay, macam mana nak cari relative extremum? This function differentiate and then setkan equal 0. Cari nilai x. So x equal to negative 1 over 4. Okay, so this is the relative extremum. Okay, relative extremum ni kita nak tahu sama ada point ni maximum point or minimum point. Okay, nak tahu dia maximum point or minimum point, kita buat table macam tadi. Okay, bagi interval and then test point, sign of f prime x dapat negative, positive. Negative meaning that it is increasing, decreasing, and then positive meaning that it is increasing. So maksudnya graph ni negative 1/4 kat sini Okay, daripada negative infinity hingga negative 1 over 4 it is decreasing, and then negative 1 over 4 until infinity it is increasing. So point kat sini kita panggil dia minimum point. Okay, so maksudnya x has the relative minimum ataupun minimum point at x equal to negative 1 over 4. Okay, kenapa dia minimum point? Sebab dia turun naik, so point dia dekat bawah minimum. Tapi kalau dekat sini positif, kat sini negatif, so positif meaning that it is naik, kat sini akan turun. So graph dia naik and then turun. So point kat sini tinggi, so kita panggil dia maximum point ataupun relative maximum. Okay, look at this example kat sini. Okay, this function kita differentiate and then set up dia equal 0. solve for the value of x, we'll get x 1 and negative 3. Okay, then buat table macam tadi, kita akan ada 3 interval lah. Okay, this one is positive, negative, positive, increasing, decreasing, increasing. So increase, decrease, increase. So maksudnya point kat sini maximum point, kat sini minimum point. Sebab itulah dia kata ni maximum, yang ni minimum. Okay. So kalau nak cari minimum point, kena cari dalam bentuk koordinat lah. Okay, kita tahu x je negative 3. Nak cari y, masukkan dekat dalam function asal. Dapat y dia 28. So the coordinate is negative 3, 28. Okay, yang ni x kita tahu 1. Nak cari y, masukkan dalam original equation. So dapat negative 4. So coordinate dia 1, negative 4. So negative 3, 28 is the maximum point. 1, negative 4 is the minimum point. Okay, example ni pula. This function, so kita differentiate equal 0. So differentiate jadi 3x square equal 0. Selesaikan x, dapat x equal 0. And then x equal 0, meaning that we can divide it into 2 intervals. And then select test point. And then insert into f prime x. So we'll get positive, positive. Both positive, so both is increasing. So kalau ni increasing, increasing lagi. So graph dia bentuk increase, lepas tu increase lagi. So tak adalah maximum ataupun minimum point. So f of x has no relative extremum. Okay, that's how we find the relative extrema. Yang ni tadi using first derivative test. Okay, kita nak cari relative extremum, sama ada dia point dia maximum ataupun minimum point, using first derivative test. Okay, kita kena cari f prime x. Okay, second way to find the relative extremum is by using second derivative test. Okay, second derivative, kita nak cari relative extremum sama. Kita nak cari relative extremum, tapi jalan kerja yang tadi guna first derivative test. Kali ni kita nak cari relative extremum using second derivative test. Okay, if f double prime x naught, x naught ni adalah test point kita. Kalau lebih besar daripada kosong, dia ada relative minimum. Kalau lebih kecil daripada kosong, relative maximum. Okay, kita tengok example. Okay, by using second derivative test, find the relative extreme minimum or maximum, okay, for this function. First kali, differentiate sekali. And then equalkan dengan 0. So kita dapat 2 nilai. So ini kita panggil dia critical value. And then differentiate 2 kali. Okay, differentiate 2 kali. Dapat 12x tolak 6. Okay, lepas tu masukkan x ni. X ni masukkan nilai yang kita dapat tadi, iaitu 0 dan 1. Okay, 0 dan 1 masukkan dalam f double prime. So kita dapat f double prime 0, f double prime 1. Okay, meaning that we need to insert 0 into this function, which is f double prime. So masukkan 0 dalam ni. 12 multiply with 0 is 0. 0 minus 6 is negative 6. And then insert 1 into f double prime. 12 times 1, it is 12, minus 6, it is 6 lah jawapan dia. So this is negative and then positive. Less than 0, more than 0. So less than 0 meaning that the function has relative maximum at x equals 0. Okay, more than 0 means that the function has relative minimum at x equal to 1. Okay, so kita dah tahu maximum dekat x equal 0, minimum dekat x equal 1. Lepas tu nak cari koordinat dia. Kita dah dapat nilai x, nak cari nilai y lah, nak cari koordinat. Ingat setiap kali nak cari koordinat kena insert dalam original equation. Original equation yang ni lah. Original function yang ni, f. F, bukan f prime, bukan f double prime. F saja. So insert 1 kat dalam F dan insert 0 dalam F. So dapatlah koordinat Y dia. So 0, negative 3 is the maximum point. 1, negative 4 is the minimum point. Okay, next. Ini kita belajar macam mana nak lukis graf manually. Okay, tak menggunakan apa-apa apps. Okay, nak lukis graph of polynomial function manually. Okay, these are the info that we need to find first before graphing the function. Okay, the first one we need to find what is x-intercept and y-intercept. Okay, yang ni you all tahu kan, kalau nak cari x-intercept, kita kena setkan y equals 0. Nak cari y-intercept, kita kena setkan x equals 0. And then find the coordinate. And then kita kena cari critical point. Critical point macam mana nak cari? Kita kena set f prime x equal dengan 0. Okay, cari nilai x. So itu adalah dia punya critical point. Relative extrema, maksudnya kita kena cari minimum or maximum point. And then increasing, decreasing. Ini yang kita buat table tu. Table yang kita tengok mana interval increasing, mana interval yang decreasing. And then concavity. Concavity pun kita kena buat table juga. Tapi berbeza table dengan table ni berbeza. So for concavity, kita kena carilah interval mana yang concave up. And then which interval are concave down. And then inflection point. Inflection point kita boleh dapat daripada f double prime x equal 0. Okay, so yang ni tak perlu sangat Yang ni 4 benda ni kita kena cari dulu. Dah dapat info semua, barulah boleh lukis graph. Okay, so you all boleh study sendiri. Example 3.21. Okay, and then yang ni tak perlu lagi. Ini adalah untuk next week punya syllabus. Okay, so untuk lukis graf ni saya akan ajar dalam tutorial class. Okay, tutorial class. So maksudnya dalam video ni you all hanya belajar 4 benda ni saja. Okay, nak cari benda 4 ni. So dah ada info semua ni, barulah kita boleh lukis graf. So lukis graf dalam tutorial class. Okay, so lecture video ni sampai sini saja. Saya akan bagi soalan tutorial selepas ni. So you all kena siapkan tutorial. Tutorial tu kita nak cari ni lah, critical point, maximum minimum point, increasing decreasing, concavity ni semua. Dah ada info, nanti baru awak bawa jawapan tu dekat dalam tutorial class, kita lukiskan graf dia. Okay, so video ni sampai sini saja. Okay, see you in our tutorial class. Okay, Assalamualaikum warahmatullahi wabarakatuh.